Hello, once anyone class. This is the last thing from 3.5 notes, and this is changing an expression that looks like this: y equals something times b to the x, where b is the base of some exponential, and changing that to base e, changing b to the x to base e. And the way we do that is we take the b to the x right here, and we use the property that e to the natural log of anything equals that anything, whatever that stuff is in the parentheses inside the natural log. And so if we have this b to the x, then we end up with b to the x. So e to the natural log of b to the x equals b to the x. So what this allows us to do is change this b to the x right here to e to the natural log b to the x, okay, temporarily, and then we use the power rule. Because it's a natural log, we use the power rule to bring that x down in front. But then the way we write it in this formula anyway is with the x after. So we're bringing this x down in front, and it's temporarily, you can write it as x times the natural log of b, which is the way we've typically written it. But this formula has it written in reverse for what we normally do, just because of the variable following the number, like we typically see. So that's the way we do it. We just take the b to the x and we replace it with e to the power of the natural log of b times x. And those things are always equivalent. Now I'm going to show you, I'm going to do some calculations on the calculator to show you they're equivalent. Alright, so I got 2 times 5 to the third. That's like a is the 2, 5 is the b, and x is the 3. So 2 times 5 to the third is equal to that. Okay, is equivalent to a again, so that's still the 2, times e to the natural log. So e raised to the natural log of b. Alright, b over here was our 5, so 5. And then close that off, and then times x, and again over here x was 3. So 2 times e to the natural log of 5 times 3, we still get 250. They are equivalent. Both of these expressions are equivalent. It's just this is base 5 exponential, this is base e exponential. Remember, exponential base is what's being raised to a power. 5 is being raised to a power here, e is being raised to a power here. Alright, so we've got a function. This is like our a, this is our b. We've got a function written this way, and we want to rewrite the model in terms of base e. We want to write it this way. So just know again that a is the same in both. So the first number, thing that's being multiplied by the exponential part, doesn't change. But now our base, we're going to write that as e to the natural log of this base, 1.017. Then the x is no longer above that. It's not up here anymore. It's now being multiplied by that. So now this model is in terms of base e. It's just typically we don't leave the natural log in there. A lot of times they'll have you round this, and usually they'll have you round it to 3 or 4 decimal places. So you just type in the natural log of that number. Alright, so I get 0.016, or change that to a 9 because of the 5. So 0.0169. Alright, so there's our value. This number gets rounded. Okay, this natural log of 1.017 is approximately this, and we round it, and then just stick the x on the end of it. Okay, so typically when we do this, instead of leaving it as the natural log of e, we usually give like an approximation for this number times x, and then it looks again like the a naught e to the k t, but this is an x, so it has that exponential growth look to it when we deal with base e. Alright, but this is something to do. This is again something important for calculus. This is the preferred exponential base in calculus. And this shows us the important thing about this is we can use base e always. We can always use a specific base, and in this case base e. Anytime that we have an exponential function, we can switch it to base e and always have the natural base.